All right, so let's talk about ChatGPT. We're going to peel back the layers on how this thing actually works, what it's really doing under the hood. Let's get into it.
You've seen it, right? You give it a prompt and out comes text that is just so fluent. It's coherent. Sometimes it's even weirdly insightful. It really feels like it gets what you're saying.
I mean, it seriously feels like some kind of magic. Is it actually thinking? Is it, sentient? Well, the reality is a little less sci-fi, but honestly, it's way more interesting once you understand the trick.
Yep, you heard that right. At its very core, ChatGPT is doing just one simple thing, over and over and over. It's constantly asking itself, okay, based on everything written so far, what's the most likely word that comes next? That's it. That is the entire game.
So how does that simple little loop, just predicting the next word, create something that feels so intelligent, so human? Let's take a closer look at this next word illusion. So when we give the model a phrase, it doesn't just pull one word out of a hat. It actually calculates the odds for thousands of different possibilities. In this case, learn might have a 4.5% chance, predict a 3.5% chance, and so on down the list. Then it just picks a word from that list, usually one of the top ones, and tacks it on to the end of the sentence. And then, here's the key, it does the exact same thing again. It looks at the new, longer sentence, calculates all the probabilities for the next word, and adds that. It literally builds essays, poems, and answers word by painstaking word.
Okay, so how does it get so incredibly good at this guessing game? Well, this is where the scale just becomes mind-boggling. The model behind GPT-3 uses 175 billion with a B, parameters. You can think of these like tiny little adjustment knobs that get tuned over and over during training, letting it capture the insane complexity of human language.
Now, to get a better feel for how a model with that many knobs actually works, let's step away from language for a minute. Let's look at something a bit simpler that we humans do all the time, recognizing what we see.
Just look at the difference here, right? A computer can easily be programmed to recognize the perfect, clean digits on the left. But the messy, handwritten stuff on the right, that takes something more like intuition. It takes pattern recognition.
And it does this with something called a neural network. It's a system that's kind of modeled after our own brains. We don't give it a bunch of rules, like a 2 has a curvy top and a flat bottom. No way. We just show it millions and millions of examples, and it figures out the patterns all by itself.
A really cool way to visualize this is with something called attractor basins. Imagine that all the different weird ways you could write the number 2, sloppy, neat, slanted, they all get kind of pulled by gravity towards one single core idea of what 2 is. The network creates a concept.
Okay, that makes sense for images. A neural net can group things that look similar. But language isn't just about looks, it's about meaning. So how does a machine that only understands numbers learn the meaning of a word?
The answer is this absolutely brilliant idea called embeddings. What the AI does is create this giant multi-dimensional map of words. And on this map, the distance between words actually represents how related they are in meaning.
So for instance, after crunching billions of sentences, the AI learns that words like alligator and crocodile are used in really similar ways. So it puts them right next to each other on its map. But a word like turnip? That shows up in totally different contexts, so it ends up way over on the other side of the map. It's a map of meaning, built completely out of statistics.
And get this, it's even more clever than that. The model can even figure out words that have multiple meanings, like the word crane. Depending on the other words in the sentence, the AI will place crane either in the neighborhood with all the birds or over in the neighborhood with all the construction equipment. It's all about context.
Now, what's really fascinating is what all of this implies. I mean, if a machine can learn to generate pretty believable human language just by predicting the next word, what does that actually say about our language itself?
It suggests something pretty profound. The fact that this whole statistical guessing game works so well means that our language can't just be a random, chaotic mess of rules. There must be some kind of deep, predictable, almost law-like structure hidden inside of it, a structure the machine was able to find.
And it learns all this stuff on its own. Nobody ever taught ChatGPT the rules of grammar. Nobody gave it a logic textbook. Just by swimming in a giant ocean of text, it absorbed not just how to structure a sentence, but the deeper logic of what sentences actually make sense. But, and believe me, this is a very big but, this whole pattern matching thing has some serious limitations. We have to remember, this is not a thinking machine. It's a mimic, A really, really good one, but still a mimic.
You can see here, ChatGPT is amazing of the stuff that's kind of fuzzy and intuitive for us humans. Writing an essay, brainstorming, summarizing, but it completely falls apart when you give it tasks that need rigid, step-by-step, logical precision, like a long math problem, or crucially, guaranteeing that what it says is actually true.
This is a perfect example. You can ask it to check if a bunch of parentheses are balanced. For a short, simple string, its pattern matching skills work just fine. But as soon as you make it long and complex, it starts making mistakes. Why? Because it can't actually count like a computer program. It's just making an educated guess based on patterns it's seen before, and eventually, that strategy is going to fail.
So at the end of the day, ChatGPT is a statistical mirror. It's just reflecting the patterns of human language that it was trained on. And by creating this incredibly powerful mimic, we've kind of accidentally built a brand new tool to study ourselves. It revealed this hidden, almost mathematical structure in our language. And the really big question it leaves us with is this: what might it eventually reveal about the structure of our own thoughts?